On page 4 of our Chapter 5A notes, we talk about rate. So recall, rate is a ratio comparing quantities of different units. For example, miles per hour, feet per second, etc. So example, and what I want to say is that sometimes graphs can be used to tell a story. So that's what we're going to do in these next few examples. On different occasions, for example 7, on different occasions, Centipede and Milady Bug traveled between the elm tree and the rose bush. So notice it says here on the vertical axis that it's the distance from the elm tree in feet, and on the horizontal axis, it's the time in minutes. So the question asked in A, the first time they started from the elm tree, the graph at the right shows their progress. How fast were they moving? So we're going to use slope to tell that. So Centipede here, we want to do rise over run. So we want to be able to do a slope triangle. So we need to find somewhere where it crossing. You can see right here, it's crossing at 3. So we're going to make this our slope triangle. So we're going to go right and up. So we're going to do rise over run, and this is going to be Centipede, so I'm going to put S here, S, and then we're going to dot M is going to be equal to rise over run. So the run is going to the right one, so going to the right one and then up 1, 2, 3 with a rise of 3. So Centipede is going 3, and this was feet per 1 second. And so then we can reduce that to be 3 feet per second. Milady Bug, so I'll call her M, Mel, her slope is going to give us how fast she's going. So for her, we're going to go, let's see, we're going across right here. So for her, we're going, there's our run, we're going to run 2 and then rise 1. So her run is 2 and her rise is 1. And when we put units to this, this is 1 foot, that's our vertical, and then our horizontal was in minutes. So 1 foot for every 2 minutes. So we say she was going 1/2 feet per minute. What did I say seconds up there earlier? This should have been minutes. Right there. My apologies. B. And B, the next graph shows their progress on the second trip. Did their speeds change as they walked away from the elm tree? Well, let's see. For Centipede, he went, over 1 and then up 3. So again, Centipede, his rise over run, so Cen, is still going to be 3 over 1 feet per second, feet per minute. And Milady, when we do hers, she's still going running over 2 and rising up 1. So Milady still is going to be 1 over 2. So run 2, rise 1 feet per minute. So did their speeds change? The answer is no, they're the same as they were in our first example. So they're moving at the same speed away from the tree. What did change? Because the lines are obviously not in the same place. So notice what did change. Centipede, started right here at the elm tree. So remember, this is the distance from the elm tree here. So originally he was at the elm tree, he was 0 feet away. But here, when he began 1 foot away from the elm tree. So Cen began 1 foot from the tree in this example. And Milady, she began 1, 2, 3, 4, 5, 6 feet away from the tree. So Milady began 6 feet from the tree. We'll complete the other examples together in class. So let's move to example 8 on page 6. describe the rate of change in each graph. So remember that a slope is the rate of change. So I want to figure the slope on this line right here. So to move from one point to the other, I'm going to move, and notice the direction I'm moving. If I move from this point to that point, my run is going to be a -3. So my denominator is -3, and my rise is going to be up 9, so that's a +9. So our slope is going to be 9 over -3. And again, the vertical change is water in a tank in gallons, so this is going to be gallons, and the change in time, which is hours for the horizontal. So this is going to reduce and become -3 gallons per hour. All right, let's just do one of these from example 9 as well. Find the change, then find the unit rate of change. So this one asks for the change in volume in 6 seconds. So my time is 6 seconds. So 1, 2, 3, 4, 5, 6. So here's our point that happens in 6 seconds. So you can see there's my run going backwards of -3. So my denominator is -3. And then I go up. I'm sorry, what was I saying? 1, 2, 3, it's -6. And then I'm going up 3. So the change in volume in 6 seconds is -3/6, which is a change of -1/2. And that would be in feet cubed per second. So the unit rate is going to be -1/2 feet cubed per second.